Hello everybody, this is Rudra Pradhan here. Welcome to Engineering Econometrics. Today we will continue with nonlinear regression modeling and that to discuss with various examples. In fact, in the last couple of lectures we have already discussed this particular unit that to highlights various forms of nonlinear modeling, starting with dummy modeling, interactive effect and various functional forms through which we can discuss and analyze some of the engineering problems and come with a kind of decision making as per the particular management requirement. So, today what we have to do, we will just take a problem and then we like to connect how actually works in real life scenario and that too with the help of a particular software. In fact, there are various softwares are there, econometric softwares through which you can solve this problem and that to work out the engineering problems with the help of various forms of the models, and then again with the help of softwares we can get the estimated results, and once we ready with estimated econometric results, then we will discuss the particular problem and we will work out the decision making process. The thing is that first of all we should know what is the exact problem and what are the various variables attached with this problem, and whether the particular problem can be analyzed with linear setup or in a kind of nonlinear setup. If it is actually solved through linear setups, then no point to come to the nonlinear setup, but if the requirement is the nonlinear, then we are bound to use that particular form, and then the decision making process will be very effective and very efficient. In fact, with the help of data visualization, you can slightly get to know what kind of model we can use or what kind of functional forms or the types of models we can allow to estimate the process and then predict the particular requirement. Sometimes if the model is means the problem itself will demand that there is need of such kind of models. For instance, I mean say the dummy modeling and the interactive effect kind of modeling is the cited examples. So, let us discuss these aspects, and briefly I will just highlight once again the various nonlinear type econometric models. Then I will take examples and I will try to find out solution for these models. In fact, same data analysis package, Excel solve package we can use to have these estimated output. Means Excel data analysis package can help the process, provided you have to do some kind of initial processing and bring into a kind of setup through which Excel data analysis can help you to get the estimated output. Otherwise, there are so many econometric softwares, the softwares are there, starting with R, eViews, Microfit, Shazams, all these softwares can be directly used to estimate these outcomes. Let us see first various forms, then connect with the kind of examples and the estimated outputs. So, altogether we have discussed dummy kind of modeling. So, where we have a dependent variables, that is the information which we would like to have this process is numeric, and then it is connected with a independent variable which is a dummy type. For instance, y is here a salary structure of the college students, means those who are just entered to the job market after the college degree, and we are interested to know here what is the difference between male income and female income. So, in fact, we have already highlighted these models earlier. I am just once again connecting this, and then I will take you to the software to see how is the kind of actual difference through software results or estimated results. So, in this case x 2 is treated as a independent variable, that to the kind of dummy. Dummy means it is a proxy, and x 2 is here gender, and usually gender information gender first hand information is the kind of male and female, which we can actually take care through software. That is why we need a transformation. So, we put 0 for male, and by default 1 is a kind of female. Then the entire data information basket will be transferred into salary structure and corresponding to the gender male female, and that will be transferred into 0 and 1 form. So, ultimately end of the day your spreadsheet will be having numeric informations, that to salary structure with numeric content, and against the kind of gender with coding either in the form of 0 or in the form of 1. For examples, this is a spreadsheet here, and we have taken actually couple of variables, and first thing corresponding to this model we have here two variables, salary structure and the kind of gender, right. So, what we will do here, you see here in the salary structure we start with 35,000 or 45,000, 20,000, 32,000, all figures are in thousands, and it is a kind of cross sectional observation. So, that means technically we have 23 samples, and then out of which some are male and some are in females. So, we like to know what is the average income difference between male and female, and this is not exactly hardcore nonlinear kind of model, but it will give you some kind of exposure to the nonlinear setup. By the way, so having this data structure, so we can come to the data analysis package. So, we are here in the data analysis, and then we will go to regression package, just put OK, and then we will find the screen like this. The way we solve earlier couple of bivariate problem and multivariate problem. So, here we just like to check gender impact on student salary, and we like to check the difference. And by the way, so let us start with dependent variable. So, we can give indication about the dependent variable here. So, this is what the dependent variable indication. So, then corresponding to the dependent variables we can give indication about the independent variables, that to here, and then we allow the software to have the estimated output and just put OK, and you will get the estimated output here. This is what the estimated output, and you will find yes, the model outcome is not so good. In fact, since the sample size is very small and it is kind of arbitrary data, and what will see here means what is more important here is the estimated output and how this dummy modeling can be interpreted, that is more important here. Then the reliability of the model and fitness of the models can be improved by adding samples more sample points, or you can actually get the actual data points and then have the estimated output. So, that is the part of the game, and because reliability process we have already gone through it, until unless you get the model will be clear through reliability and diagnostics, we cannot use for the predictions. But what is more important here, after getting the reliability and the diagnostics, how we can interpret finally, that is what the beauty of this dummy structure. And here this intercept is very important. So, the model by default will be y equal to alpha beta x, for instance like this here. In this case here y estimated is equal to b 0 b 2. So, now b 2 is the slope coefficient and b 0 is the intercept coefficient. So, now if we look here, so the intercept is actually 14.63 and the x2 coefficients is coming 0.98. So, now 14 and approximately 1. So, 14 1. So, slope coefficient is approximately 1 and intercept approximately 14.6 means 15. So, it is the game between 15 and 1. So, now you come here and here the interpretation is if actually x 2 equal to 0, then we have y cap equal to simply b 0 and that too the average salary for female only, because when we put actually x 2 equal to 0 and that too for male, that particular component will be removed, and that means technically if you put here actually x 2 0 and then the entire component will be 0. So, then finally, y cap equal to b 0 only. So, b 0 is coming here 15. So, that means technically, so when when x 2 equal to 0, then the y cap equal to simply b 0 and that represents the male income, male average income, that means average salary of male group, and here it is 15, and then when you put x 2 equal to 1, then b 2 is already equal to 1. So, 1 into 1. So, it is equal to 1 again. So, then 15 plus 1. So, then that impact will be female income. So, that means technically y cap equal to b 0 and y cap equal to b 0 plus b 2, and here b is equal to 15 and by the estimated Excel output, and then b 2 is equal to 1. So, that means technically when it is 15, then this is 15 plus 1 16. So, only 1000 extra is the kind of difference. So, that is what the dummy modeling can find out the difference between or classify the entire sample into two groups or the same problems analyzed in a different kind of structure. In fact, it is the kind of requirement we are interested to know the gender difference income difference among the or between the male and female. So, that is how the structure usually follow and find out the difference, whether there is a difference, and again we sometimes know whether the particular difference is statistically significant or not. Of course, there are other way we can find out the difference, like you can put simply t statistic and ANOVA, divide the sample into two parts, male income and female income, then check the difference whether statistically significant or not. In regression, what we will do? We add all these samples, create a single sample and regress it, then you will find the kind of difference. So, both both ways you can find out the inference, and in fact, this is more interesting because we are analyzing the particular sample in a one single structure. So, likewise, we will find different kind of structures through which you can actually understand the dummy modeling, and then the second form of this structure is nothing but called as interactive effect, because I am just connecting all these forms what we have already discussed, and every model means various forms of nonlinear models, and then I will connect with the problems and the software output. That is what the kind of requirement here. And in the interactive effect, because with one variables we cannot study the interactive effect, and for this so we can start with trivariate setup, and in this case so we have two variables, x 1 is a independent variable and x 2 is independent variables. So, by default the interactive effect will be x 1 into x 2. So, obviously, so we start with actually y means the original game is y equal to function of x 1 and x 2, then finally, the model will extend to y equal to x 1 x 2 and x 1 x 2, that is the interactive effect. So, as a result, so we have a 4 coefficients, beta 0 is a intercept, beta 1 is the slope coefficient for x 1, beta 2 is the slope coefficient for x 2, and beta 3 is the slope coefficient for the interactive effect, that is the intersection between x 1 and x 2. So, obviously, this is what the form of the interactive model. Now, we will see what is x 1, what is x 2, and then we will see the kind of interactive. So, that means this is a specific types of models which may not used frequently. Depending upon a particular engineering econometrics problems, we can actually specifically use. This is very special kind of models. Of course, all the nonlinear regression models are special in special character or special kind of models, but this is very special. In fact, for that you must theoretically understand that the interactive interactive effect is a additional variable which can be actually logically created and theoretically justified. Then after that you can add these variables and check the kind of not necessarily every time you can include even theoretically sound or logically supported, still you see whether there is a significant contributions. If so, then you can incorporate, otherwise you can just check and remove. Then finally, we need actually the estimated model which is actually absolutely okay for the decision making process. So, now for that we can go to again Excel sheet, and in this case, so we can go to the data sheet first, then here the data sheet, and before that actually, so what I can do, I will just connect with this models. So, what we can do, so let us take an examples. Okay. So, x 1 x 2 and the interactive effect. For that actually we take actually x 1 equal to male and x 2 equal to merit, and again we put another variable x 3 divorce. So, that means 3 independent variables here, and then we like to see the interactive effect, because this model which we have already discussed in the previous lectures, the sample models to describe the interactive effect, in the same models I am just using to connect with software outputs, how it works, and ultimately what kind of results you will get and how you can interpret. That is more important here. And we have here 3 variables. This is in fact x 1, this is x 2, and this is x 3. This is x 1 versus x 2, and this is x 1 versus x 3. Okay, x 3. So, male married and divorce, then male married and male divorce. So, that is the kind of so every time the target is actually gender, and that to specific target on male sides. So, by default the first variable will be the gender. So, the information in that particular variable will be in the form of 0 1, and again married, the answer will be simply yes and no, and that will again transfer into 0 1, and again the third variable is divorce. So, that will be again yes no, and the final input will be again 0 1, and then we have now 3 variables altogether, male, married, divorce, all are dummy type. But for interactive effect, not necessarily variable should be interactive or dummy type, and it may dummy type, it may not dummy type, but in this specific examples it is the mandatory that we should have dummy type, because the type of variables is like that only. And then simply what we can do, male merits, that is the interactive effect, one interactive effect, then male divorce, that is the another interactive effect. So, we like to check how male impact on salary salary, average salary, then merits impact on this average salary, then what is the divorce impact on salary, then again the kind of interactive effect. For that we have actually created here the kind of examples, and for that, so this is what the kind of understanding, the detailed description about this model. And then let us see, we will work out here how it can be operated in real life situation. See here, we have 3 technical variables, x 1s, then x 2 and x 3, and then what we will do, we will create an interactive effect, male and married. So, that just you put equal to signs, and this is what actually male and females, that is transformation is 0 1, just you multiply and have this particular variable. So, that means this is the integration between this and this. So, you just put OK, So then you just generate this series. So this will be the first interactive effect. So the data set will be created, and then second variables inference will be like this. This is what actually okay. So this is what actually male merit, okay, and then in this case we will put here male divorce, right, male divorce. This is what male divorce, okay. So that means this is another variable which we will create. So equal to, that means this and the kind of this. So this will be created again. So now we can generate this series. So now the data set is ready. I am doing this because the data analysis Excel software is directly cannot take. So you can actually manually process it, then allow this software to run the model. So now what is happening here? We have actually here the dependent variable, then first independent variable, second independent variable, third independent variable, and the first interactive effect and the second interactive effect. What the structure of the model is here, and then we use this models and then go for the estimation process. So ultimately you can go to the data analysis package again and highlight the regression, then you can actually reset, because earlier set was the kind of the structure about the dummy representation. So here, so the same dependent variables. So the dependent variable will be like this, okay, and then the kind of independent variables. So what will you do? So we will take all the independent variables simultaneously. For these dependent variables, it includes both independent variables and the kind of interactive effects. So here three independent variables and two interactive effect, and now here is the output. So this is what the output. So now yes, of course this there is a little bit improvement corresponding to the previous model outcomes, and of course it is not so good because f is not coming statistically significant and r is technically very low, and again adjusted r square is also very low. So what is happening here? So what is more important here? The coefficients, and here this is the intercept, and this is the first independent variable estimate, second variable independent variable estimate, and third independent variable estimate, then first interactive effect and second interactive effect. So that means, see, the ultimate after getting this estimated output, you can again come back to the kind of discussions. So here, so just put this coefficient in place of betas, because we have all these beta results including alpha, and then what is the difference here. So every time it should be 0 1 kind of structure. So that means when you put actually 0, then ultimately it will go to the female structure. So when it is actually male, it will be 1. So ultimately, so the effect will be here alpha plus beta 1s, or simply alpha. Then if it's a yes no, so again, so if the guy is married, then it's 1, not, then it will be 0. So then again, so every time you can actually put allow 0 and allow 1. So then you will find big difference. Then finally you can have the outcomes and then check the interactive effect, whether it is statistically significant or not. Of course the theoretically this model is okay, it there is a possibility of adding interactive effect. Ultimately the best requirement or the effectiveness of model depends upon the statistical reliability or econometric reliability. That means technically it will pass through all the reliability test and the diagnostic test. Then after that you can interpret how is the individual variables impaired and how is the interactive effects impaired. So it's like more or less same like as usual multiple regression. So after creating interactive effect, which is logically sound, theoretically okay, then there is no issue to go ahead with the estimation process, get the estimated output, interpret the model and go for the decision making things as per the particular engineering requirement. So this is a special type of models. Then after that we have a various types of other nonlinear models, starting with quadratic form. So here's the kind of structure is same. Y is the dependent variables and x is a kind of independent variables, and x2 is a kind of independent variables, and we are allowing x1 in a kind of nonlinear format. So that means technically, so we have here actually y x1 and x2, and then we will create a x1 square. It's not actually big deal. So we have a dependent variables and we have x1 and we have x2, like we have created an interactive effect, for instance male male married and male divorce. So here also you can create x1 square, that is again kind of an interactive effect. So there x1 x2 or x1 x3, it's a kind of cross product interaction. So x1 square is a kind of dot product interaction. So you can multiply variable with x1 with x1 and x2 with x2. Of course, creating this kind of variables by the help of dot product, it should be again theoretical sound and logically supported. So then after that you can have the data generating process, and then you had to go with the a kind of estimations and can have the estimated results. For instance, again you can go to this the kind of Excel sheet. So let us say this is actually a kind of what you can call it as original data sets. Let us say this is actually y, and we will create a let us say another kind of x 1 squares. Let us say this is the kind of thing. So what will you do, provided this is x1, and so what will you do, so you just put square equal to here, and this again multiplied by this, okay, multiplied by this, and then you created this particular variable. In fact, this is a dummy kind of representation, it will not change at all, it will change at all, but it can be created like this. Okay. After this variable creations, so what you can do, again you go to the data analysis package and then put the as the kind of regression requirement. So reset again, and here the requirement is actually dependent variables. So first you go to the dependent variable structure. So this is what the dependent variable structure, and here in the case independent variables, so you can actually allow gender, okay, then this ones, and again and the interactive effect, okay. So then you put okay. So this will come like this. So that means the process is more or less actually same. So you will have a kind of output, and after getting this output again come to this interpretation. So that means you create x1 square is a third interactive type of variables, then again you run the models. So you will get a kind of estimated outcome, and then check whether the estimated outcome is statistically significant or not. For instance, here we have two different kind of structure. In one case we have y equal to beta 0 beta 1 x 1s and beta 2 x 2, and then again in betweens we are allowing beta 3 x 2 x 1 squares, and then check whether the particular interactive effect will be statistically significant or not. If that is the case, you can go ahead and then you see how best we can interpret the kind of requirement. Then in the same times you can have another form of the models like here, and this is a exponential type models, or sometimes in business or management. So we call as CD type production function, Cobb-Douglas production function. So here the forms of the connection are completely nonlinear. So what we can do, the entire models can be transferred into linear format. For instance, the first in the original model in fact is like this. So, this is what the original model. So, what we can do here, we will go for transformation. So, that is actually the best way to bring into the linear format. Then after that we can go ahead with the Wallace mechanism, and we can estimate the process and have the estimated output, and after that the interpretation process will be more or less same. So, in this case we have y beta 0, then x 1 to the power beta 1, x to the power beta 2. So, that is here. Okay. So, what will you do here? So, we can apply log transformation both the sides, and mathematically it is allowed, and that is the best way to simplify the structure and go ahead as usual simple OLS mechanism. So, now so we have actually originally we have y x 1 and x 2. So, now the transformation process will be ln y, ln x 1s and ln x 2. Okay. So, this is how the three variables can be created. So, this is the original and this is the transport data. Now, once you have a transport data, so the log y can be treated as y, then it will be simply alpha, then let us say alpha 0, then this will be say alpha 1, say small x 1s, then plus alpha 2 small x 2, and then the error terms. So, now the same models can be represented in this form, where y is nothing but log y, then alpha 0 is nothing but log of beta 0, and alpha 1 is nothing but actually beta 1, and x 1 is nothing but log x 1, and alpha 2 is beta 2, and then log x 2 is nothing but small x 2, and then log epsilons will be the error terms. So, this is how the final transformation, and then in order to simplify the structure. So, what we can do, it is actually a model transformation is required. So, again you go to the Excel Excel spreadsheet, and this is how the original data set. So, what will you do? So, we will have here transformation. For instance, you can go ahead with log transformation. So, just you put OK and allow here actually a log transformations. Okay. All right. So, yes, this is what the log transformations, and then you can just indicate the particular variable and put OK. So, this will be created here. So, this once you transfer, then you can generate this series. This is actually say log of y. Okay. And similarly, we can go for this variable transformation. So, that means the entire variables original setup is like this, and this is the transport system. Of course, these independent variables are dummy, and it is in the form of 0 1, which cannot be transferred here. So, for that the sample structure will be changed, but y is actually numeric. So, that can be go for log transformation again. So, with this samples data set, it is very much clear that in this form of linear regression models, the first and transformation should not be actually 0 1 type, that means dummy type. So, it should be absolutely numeric, so that you can go ahead with the transformation, proper transformation, and then you can use this transport output for the estimations, and then we can go for the decision making process. If that is not the case, then you cannot use this form of model to go ahead with the estimation process and as per the kind of engineering requirement. So, this is another form of nonlinear regression models, and in same way. So, this is a square root transformation, same thing, instead of log y. So, we have here originally we have actually y x 1 and x 2. So, now same y will be remain there. So, instead of x 1, you can go for x 1 square root of x 1 transformation and square root of x 2 transformation. So, usually the idea is reduce the volatility and put in a kind of structured form, and again you re-estimate the process. Then the process of re-estimations with the transport output will be more or less like the original structure, and then you can interpret. Of course, the kind of elasticity of these outputs will be different, but more or less the processing through software is very much similar. So, it is not actually big difference, just you need actually data transformation, and if your model is behaving like this, and for that you can actually go for data visualizations, like here we have actually gone checked actually, then we can transport the model like that, and then we can apply the transport output for the model estimations, and that too as per your requirement. This is what the transport output. And again there is another form of models, nonlinear regression model, that is exponential types of again. So, this is the originally it is a nonlinear. So, you can apply log. So, log of y equal to beta 0, beta 1 x 1, beta 2 x 2. So, that means here this in this case only log y can be transferred, means y can be transferred to log y, then x 1 x 2 as usual remains same. So, that means compared to previous one. So, one way you can first find out y and log x 1 and log x 2. So, like this case, and then you can actually keep y remain constant, and x 1 will be changed to root x 1 and x 2 can be changed into root x 2, and then go ahead with estimations. And in the third case y can be log y, and that is the only transformation you do, and the remaining beta 0, beta 1 x 1, beta 2 x 2. That means x 1 and x 2 is the original kind of requirement. Then go ahead with the estimation process. So, the estimation process altogether actually same, and ultimately you have to just check various forms, and the same problems can be processed through various other forms. That is one kind of robustness check, and by default you will find various alternatives, same variable, same problems, and just we are changing the various modeling forms, various with respect to various functional forms and structural form. Then you check with estimations, and the model which is really good and best as per the reliability is concerned, diagnostics are concerned, then that model will be finally kept for the decision making process and as per the particular engineering problems requirement. So, with this we will stop here, and thank you very much. Have a nice day.